This plane, the F-15 Eagle, was built for one purpose and one purpose only: total air superiority. It was created to combat the threat posed by the Soviet MiG fighters during the height of the Cold War in the 70s, and was the first strike plane that could detect and kill from many miles away, as well as engage in dogfights. It's still in operation today, and in 30 years of active service, it has never been shot down in one-on-one air combat. It is the benchmark by which all modern strike planes are judged. The F-15 has seen active service in both Gulf Wars and is now keeping the peace, patrolling the skies above the west coast of the United States with the Oregon Air National Guard, constantly on the lookout for any threat to the U.S.'s national security.
I'm Mo Gass, a major in the Oregon Air National Guard, and I fly the F-15.
My name is Paul Fitzgerald. I'm an F-15 pilot for the Oregon Air National Guard.
Major Dale Bennett, known as Mo Gass, and Major Paul Fitzgerald, known as Snap, are former airline pilots, but now they work as fighter pilots at the Air National Guard. They are on alert 24/7 and are ready to scramble and shoot down intruders at a moment's notice.
The F-15 is a pretty incredible airplane, actually. Thinking about its design was in the late 50s, 60s. Came off the production line in the mid-70s, so it's been around for quite some time. It's a pretty powerful airplane. It was actually built to rule the skies and strictly in an air superiority type of a role, and it has not lost in battle yet, and I don't think it's going to lose anytime soon.
The F-15 first flew in 1972. Over 1,200 were built, and now there are still over 500 flying on active duty.
It's a pretty big airplane. It was actually built to house the radar that lives in the nose. The airplane is about 43 feet tall, about 63, 64 feet long, and at the tail it's just under 20 feet high. So it's a pretty large airplane. It's been akin to the size of a tennis court.
As well as patrolling the skies for intruders, the pilots of the Air National Guard also carry out training exercises. Mo Gass and Snap are planning a simulated dogfight where they will practice shooting enemy planes out of the sky.
Mission objectives for the Blue Air is quick kill.
Being a frontline fighter pilot is a hazardous job, and every time they fly, they may encounter the enemy and have to deploy lethal force.
My mission then is to turn them into hair, teeth, and eyeballs. Realistically, it's kill or be killed. And fortunately, I think all of us have resolved ourselves to the fact that you're taking out the other guy's airplane. If he has a good ejection seat, then it's a good day for him. If he doesn't have a good ejection seat, then that's one of the dangers and the threats that we live with.
The F-15 carries a range of missiles and a cannon with 900 rounds of high explosive bullets.
We have two arenas we normally fight in. It's within visual range and then, of course, beyond visual range. Within visual range, I have a 20-millimeter cannon that's in the right wing root of the airplane. Once you start moving into a little bit further out into miles and so, we start talking about the heat-seeking missile. And then once you get beyond that range, now you start talking about the advanced medium-range air-to-air missile that we use, otherwise known as the AMRAAM.
The real benefit of the AMRAAM is its ability to really get out there and reach out and touch someone and turn them into pieces and parts.
The F-15 has two giant engines producing a combined thrust of 46,900 pounds between them, capable of pushing the plane to a top speed of 3,000 kilometers per hour. That's around 3 times the speed of a 747.
The thrust that you get out of these airplanes gets you off the ground fast and it gets you to where you need to get fast.
The biggest advantage having a great thrust-to-weight ratio is the ability to power through a turn and to not only turn as quick as you can, but also to be able to sustain that turn in combat. It might take, in order to kill the enemy, it might take 3 or 4 360-degree turns in order to successfully get behind them and get in a weapons engagement zone and to either shoot a missile off or to shoot the gun.
But turning at high speeds exerts massive forces known as G-forces on the pilot. 1 G is the force of normal gravity. When the pilot makes a high G turn, the weight of their body is multiplied by the same number.
6.5 right there.
At 6.5 Gs, a 76-kilogram pilot would feel as if he weighs 6.5 times as much. That's 496 kilograms.
In order to be able to cope with the 9 Gs that the airplane will pull and actually sustain for a little bit of time, they give us several different pieces of equipment to help that happen. That's the Combat Edge Vest. It fills up with air, keeps the internal pressure in your chest cavity, so the blood can actually get pushed out of your chest cavity and into your head. Most important is your G pants too, G suit otherwise known as. It tightens up. It also moves the blood from your lower extremities into your chest, and obviously to try to keep the blood in your head so that you can keep blood in your eyes so that you can see and think. The color goes out of your vision first. The second thing that goes is obviously you have tunnel vision, and that's followed by stages of going unconscious, and that's the whole reason we're trying to avoid that. You don't want to be manipulating the controls of an airplane when you're unconscious.
The pilots also wear a helmet with an oxygen mask in case the cockpit were to depressurize at high altitude, something no pilot wants when engaging the enemy at 9,000 meters. F-15 pilots Mogas and Snap from the Oregon Air National Guard are going on a dogfight training exercise. They are going to simulate shooting an intruder out of the sky by locking their weapons onto each other in a mock dogfight. Before each flight, the pilots carry out one final check to make sure that the plane is airworthy. Even though the F-15 is an old plane, it is still the premier air-to-air combat fighter in operation today.
You have an airplane that's been around for 30 years, and still there's countries out there that are still trying to build airplanes to counter this airplane specifically. And I think that's attributed to the continual attention this airplane's been given over the years to keep it at cutting edge.
Mogas 1 and 2, AB climb to 15,000 is approved. Departure end cable indicates up. Wind 260 at 6, runway 28 left, clear for takeoff, change to departure.
Mogas 1 clear for takeoff with quick climb, and say again the freak for departure.
Departure frequency 299.2 for Mogas 1 and 2.
2992 for Mogas push 9.
By the time you get down to the end of the runway, you're doing 300, 400, 500 miles an hour, and then you can basically just take off straight up into the air. It's quite a sensation. It's like being on the tip of a rocket.
By the time you reach the end of the runway, your gear's up, your flaps are up, and you're ready to pull. You go straight up in the air. You're ready to pull a nice 7G turn straight up to go vertically, and you can get up in a hurry that way. It'll certainly wake you up in the morning.
The afterburners can push the F-15 to 4,545 meters. That's 4.5 kilometers up, in less than a minute, reaching twice the speed of sound, but at a cost.
Anytime you use afterburners, you're going to increase your IR or your infrared or your heat signature.
This would make the plane vulnerable to heat-seeking missiles, which could lock onto the heat exhaust from the afterburner and shoot the plane down.
You're also using a heck of a lot more gas because it's raw fuel in order to get that afterburner working. So you have a fuel disadvantage by having to use it, and obviously you have a heat signature disadvantage.
Once they reach 9,000 meters, Mogas and Snap start their dogfight training exercise. They take turns being the hunter and hunted. One plane acts out the role of the enemy, while the other chases and attempts to lock on its weapons guidance systems. Once the hunter plane locks on, he registers a kill.
Joint strike kill right there.
A strike for MOGAS. Had this been a real intruder, they'd now be nothing more than charred metal and smoke. Even though the F-15 is well past its shelf life, it will continue to be the U.S. Air Force's premier air-to-air strike fighter until its successor comes into service in a decade.
I believe it still does rule the skies. There's specific airplanes that do other things probably a little better, but when you take the overall package and you talk about the overall airplane, it's still a top contender in the world and probably will continue to be until we bring the new one online.
It's just a beautiful airplane. I don't think that in the history of mankind, I don't think we will ever build a more beautiful airplane, and it's just a real joy to fly.
The F-15 has proved itself in combat time and time again, but it has one huge disadvantage. Because of its size, it requires a 2.5-kilometer long runway. This means that it can't operate from small airfields close to the battlefield. What was needed was a plane that could take off from anywhere. This is the Harrier Jump Jet, a plane that needs no runway at all. It can do things that no other in-service jet plane can perform. It can take off vertically. It can take off with a short runway. It can even hover. Built originally in the 1960s, the Harrier Jump Jet revolutionized fighter plane design. Over 800 Harriers have been in service around the globe, taking off from land and sea.
My name's Squadron Leader Jim Provost. I'm a Harrier pilot on 1 Squadron. I've been flying for approximately 12 years, and I joined the Harrier in 1994. The Harrier concept came about many, many years ago during the Cold War. Its design was to be able to take off from very short surfaces, to land vertically in case there were no runways to make use of. And we're talking about a concept that was in the 50s, and yet it's still going into the 21st century. What makes the Harrier special is the fact that it can land vertically. It can land on a ship, it can land in a clearing in a wood, which makes it very special.
The reason that the Harrier can perform these incredible maneuvers is its extraordinary engine system. There are 2 air intakes, but only one massive Rolls-Royce Pegasus engine.
First point to note is that there's only one engine on the Harrier. People often make the mistake thinking that there are 4, but there aren't. You see through the intake here, there's the Pegasus engine. It's a big engine and provides all of the thrust for the aircraft. If we look down the right-hand side, we can see what we call the nozzles. We've got a hot nozzle at the back here and a cold nozzle at the front. Same on both sides, so we have 4 nozzles that take the thrust from the one engine. What that does, it provides normal thrust for forward flight, just like any other fast jet. And if we bring the nozzles down, which you can control from the cockpit, that gives you your thrust for your vertical landings and your vertical takeoff.
The plane's entire weight is supported on the downward thrust of its engine.
When the Harrier comes to the hover, obviously most of the thrust goes from the engine to the 4 nozzles on the fuselage. What we need to do, once it's in the hover, is control it. The way we do that is by diverting some of the thrust to the puffer ducts, as we call them. We have puffer ducts in the wingtips, puffer ducts in the tail, and also the nose. And what that does is provide control in all axes whilst it's in the hover. If you didn't have that, then the aircraft would just fall out of the sky. It'd be on a pillar of thrust, and you'd not be able to control the roll, or the pitch, or the yaw.
By blasting small amounts of thrust out of these puffer ducts, the pilot can balance the plane in hover and can even use them to perform delicate maneuvers. He can even get it to fly backwards. However, if the Harrier is fully loaded with weapons and fuel, it hasn't enough thrust to take off vertically, so it uses a traditional takeoff, but with a much shorter run, just 454 meters. When hovering, the Harrier needs constant pilot input. This is particularly true when operating from an aircraft carrier.
The thing can't hover and land by itself, so there's lots of things that the pilot needs to do. He's got to be able to maneuver the aircraft safely over a very small area and be able to land it. So there is a lot of pilot input that you don't get on other aircraft types. This is the Harrier cockpit. It's I think it's fairly basic, but I guess to people looking at it, it seems fairly complicated. Once you know your way around it, it's actually fairly simple. What it has, standard stick for fast jet, and it's designed very much to be a hands-on throttle and stick, so you don't take your hands away from that very often. One control that the Harrier has that other fast jets don't have is this control just by my left thigh, which is the nozzle control, which is obviously a very fundamental part of how the Harrier flies. Very small control, but apart from the stick and the throttle, that's probably the most important control in the aeroplane. Harrier can go anywhere in the world. It can operate from almost any terrain. It's proved itself in desert warfare, temperate climates, the Arctic. It can also operate from the ship. It can land on almost any surface, and it can carry a large weapon load. We can compete with the very best. We can go a long way, we can go very high, and we can bring precision weapons, which is where warfare is, to the fight.
Like the F-15, the Harrier is getting old, and by modern standards requires a huge amount of pilot input just to keep the plane in the air, when they should be concentrating on the enemy. Also, its inability to go faster than the speed of sound could put it at a disadvantage when up against faster jets. The answer is the F-35, the Joint Strike Fighter, the only aircraft in the world that is supersonic and can take off and land vertically.
I'm Lieutenant Colonel Art Tomasetti, United States Marine Corps test pilot for the Joint Strike Fighter program.
In 2001, Lieutenant Colonel Tomasetti achieved a real milestone in aviation history. Flying the prototype JSF, he was the first man to do a short takeoff, followed by supersonic flight, finishing with a vertical landing, all in one mission.
It showed the versatility of the airplane to be able to have a supersonic capability, but still have the capability to land anywhere and take off from just about anywhere it provides you.
The JSF achieved this extraordinary feat due to its unique engine system, which is based on the same principles as the Harrier. The engine has a large rear nozzle that can be directed both backwards and downwards. But it also incorporates a new piece of technology that the Harrier doesn't have, a massive fan just behind the pilot, powered by the engine.
The lift fan allows a tremendous amount of thrust to be harnessed out of the propulsion system and give the airplane a capability to do its vertical part of its work with a lot more payload than we've ever experienced in airplanes before.
To take off vertically, hover, and land, doors open along the fuselage, and air is sucked down by the fan and pushed out the bottom of the plane. So the aircraft balances on two pillars of thrust.
The rear nozzle, in addition to pointing straight down, can twist in yaw, which allows the airplane to pivot in the sky and perform 360-degree turns. The airplane can fly sideways, the airplane can fly backwards just by vectoring the rear nozzle.
This propulsion system is controlled by computers.
Unlike previous airplanes, for example in the Harrier, where the pilot has been responsible for controlling the thrust vector and making the inputs required to have the airplane do all those maneuvers, the JSF airplane, the pilot's just going to ask for go forward, go backwards, turn left, turn right, and the computers now are responsible for wiggling all the parts in the airplane necessary to achieve that maneuver.
The use of onboard computers to help fly the plane is now essential in all strike planes and has totally revolutionized the face of air combat. Computers are now used to fly planes that humans simply couldn't keep in the sky. The first plane to pioneer the use of onboard flight computers was the F-16 Fighting Falcon. The F-16s of 4th Fighter Squadron at Hill Air Force Base near Salt Lake City, Utah, are on standby, ready to deploy to a war zone at a moment's notice.
I'm Major Tom Hagen, F-16 pilot with the 4th Fighter Squadron.
Major Hagen has been an F-16 pilot for 10 years.
Well, the F-16 was originally designed as a low-cost, lightweight fighter, and now it has evolved through many years to a very high-tech weapon system. We drop many different types of air-to-ground ordnance, so it's a very, very dynamic jet.
Major Tom Hagen and 3 other F-16 pilots are going on a bombing training mission. In peacetime, they practice at least 3 times a week. Even on training missions, the pilots put their lives on the line.
The major danger is the ground. Our #1 concern when we're flying low altitude is to not hit the ground, so maintaining our altitude awareness and our situational awareness with respect to terrain and each other is a major issue.
The F-16s of 4th Squadron are strike bombers designed to take out targets on the ground.
Our primary job is dropping bombs, primarily laser-guided bombs. We carry just about all different types of bombs that you might imagine. 2 different types of air-to-air missiles, rockets for marking targets and whatnot. So just about every piece of ordnance that you can think about, we carry on the jet.
The F-16 is an extremely agile plane, something it achieves with a revolutionary design concept. It has an airframe that is designed to not stay in the air. Traditional planes like the F-15 or civilian airliners have stable aerodynamic airframes that will naturally return to level-safe flight if left to their own devices. The F-16 uses an entirely different concept built into its design and manufacture. It has an aerodynamically unstable airframe that constantly wants to bank and spin, and that willingness to turn helps the plane to perform complex maneuvers. But of course, the more unstable the design, the less the plane wants to right itself and stay in the air. The only solution is to have a powerful onboard computer constantly correcting the inherent instability by moving the flaps, rudder, and ailerons thousands of times a second in conjunction with the pilot's inputs. Without the computer, the F-16 would literally fall out of the sky.
From the pilot's perspective, it's very stable. From a aeronautics perspective, it's an unstable aircraft.
With a single powerful engine, the F-16 is much smaller and lighter than the F-15.
Well, it's a big acceleration, roller coaster rides, whatnot. It's very difficult to imagine that, but it's a big kick when we start running down the runway. The engine has an afterburner on it, so we can select AB thrust, which gives us about 28,000 pounds of thrust. It goes up to speeds of 800 knots and 2.0 Mach, so it's a very fast jet as well.
Unlike the F-15, which doesn't like to fly down low, the F-16 can operate at any altitude.
We work in all altitude regimes from way down at 100 feet all the way up to the high 30s. We can bomb from very, very low to very, very high. From the various campaigns that we've seen in the past 20 years, it's an extremely lethal weapon system.
Like the F-15 and the Harrier jump jet, the F-16 has been a very successful frontline strike plane, but it too has one great weakness. It can be detected by radar, and so could be vulnerable to anti-aircraft fire or surface-to-air missiles. What was needed was a plane that was invisible to radar, a plane that was stealthy. The only foolproof way to avoid being shot down while attacking deep behind enemy lines is to make sure no one can see you, to make yourself invisible to radar. On the edge of the White Sands Desert in New Mexico is Holloman Air Force Base, the home of the most radical strike plane ever created, the stealth bomber, the F-117 Nighthawk. A plane so strange that when pilots saw the first one, they thought it was a joke. It may look like an alien spaceship, but the F-117 is the logical step forward from the F-16, a strike bomber that cannot be detected by radar.
I'm Major Trey Urso, and I fly the F-117 stealth fighter.
Major Trey Urso's job is to constantly evaluate the F-117.
The F-117 was designed and built to enable it to fly into the most heavily defended areas on Earth. Its design optimizes its ability to get into those areas without being detected, tracked, and shot by the enemy.
The key to its success is its shape, angles and surfaces that do not reflect radar beams.
It was designed so that it could penetrate heavily defended airspace, and any enemy radar systems that might be looking for that aircraft will either be deflected away or will be absorbed by low observable RAM cover. Anytime you've got an edge, you have the potential for a radar to see that edge. So there's some really smart engineering that went into to make sure that those edges are all optimized and as flush as possible to ensure there's no radar cross-section bloom to the enemy radar systems.
Any irregular shapes, such as fuel tanks or weapons, which would reflect radar signals, are hidden inside the plane. And because the engines are baffled, on approach, the plane is almost silent to anyone on the ground.
Well, hopefully by the time the enemy would hear an F-117, the bombs have already gone off and we're well on our way home.
To further minimize detection, the F-117 only attacks at night and alone.
It's a completely different mindset when you're flying this aircraft. Unlike other frontline fighters, we typically employ by ourselves. We will fly into and out of combat zones on an optimized route that will give us the best chance to get into and out of that area without being detected and or engaged by the enemy.
Because they attack under the cover of darkness, they use night vision to identify targets.
The F-117 utilizes infrared target and tracking systems that basically gives us a TV picture of what's out in front of us. Once we see the general area that we're flying towards, we can then move the aircraft and funnel ourselves towards the target that we're trying to go after. We'll essentially see a black and white picture of the target that we're going after and be able to employ ordnance onto that target by visually identifying it.
When the F-117 was originally conceived, the first priority was to make it stealthy. The result was a design that was incredibly unstable. But using the lessons learned from the F-16, the designers were able to get the strange airframe to fly, using a sophisticated computerized fly-by-wire flight control system.
The F-117 cannot fly without its computers to help it. It's a fly-by-wire aircraft, and without those computers, the aircraft basically doesn't know which way is up and which way is down. When we're in a combat zone and we're focused on getting our weapons onto a target, we're basically on full autopilot, and we let the aircraft fly itself into and out of those heavily defended areas.
Without computers to keep the plane flying, the lone pilot could easily become overloaded, which could result in them missing a target or even hitting the wrong one.
There's no other country in the world that has anything like it. There's no other aircraft flying today that has the capabilities of this aircraft.
The F-117 revolutionized the evolution of strike planes. Its successful combat record has demonstrated the effectiveness of stealth in warfare. But even this amazing plane can't do it all. It can't achieve supersonic speeds, and if seen by the naked eye, it is vulnerable to fighters as it doesn't carry a gun. What was needed was a fast, stealthy strike plane, the FA-22 Raptor. In creating the FA-22, its U.S. designers have gone for broke, building the first ever air-to-air fighter with a stealth capability, and the first stealthy plane to go supersonic.
Hello, I'm Lieutenant Colonel Dave Rose, and I fly the FA-22 Raptor.
Lieutenant Colonel Rose is part of a team carrying out flight testing on the FA-22.
The FA-22 Raptor will be the aircraft that goes in there first and not only clears the skies of air threats, but also with the air-to-ground munitions can go in there and basically take out emerging threats.
This plane is the culmination of over 2 decades of design and testing and has incorporated the best features from all the strike planes currently in service.
The special thing about the Raptor is we've taken lessons learned from the ages of air combat, and we've taken the attributes of what would you like to basically do your job as a fighter pilot, and we put them into one aircraft. Stealth has been around a long time. With the FA-22, we call it 4th generation. We've taken all that lessons learned to not only be able to, from a shape or applications, to not be seen or to be seen very late by threat radars, but also be able to maintain that. So it's not just go for one mission. I need to be able to maintain that on the ramp for a persistent capability.
The F-117 had to be angular to be stealthy, but advances in stealth technology mean the FA-22 can have familiar curved aerodynamic surfaces and still remain invisible to radar. The Raptor carries powerful electrical detection systems that can scan the airspace up to 1,180 kilometers around it. This ability to spot the enemy from such a large distance, combined with its invisibility, gives the Raptor pilots an unbeatable advantage in combat.
First thing with the Raptor is they don't see you. I see them, but they don't see me. So now if I need to, I can go ahead and engage them and make them go away. Now I can get into within visual range, and with, again, my stealth and capability to maneuver, very quickly I can attrit that threat and leave the area. So I lose a lot less heartbeats.
Unlike its predecessor, the F-117, the Raptor is very fast, reaching nearly twice the speed of sound. It has 2 staggeringly powerful engines that produce 70,000 pounds of thrust. It also has a secret engine advance called Super Cruise that maintains supersonic speed without using an afterburner.
The Raptor was built to actually maneuver at high altitude, above 50,000 feet, and to be able to go up there and what we call Super Cruise, essentially go supersonic, faster than the speed of sound, without using the afterburner, so I don't use a lot of fuel.
Super Cruise has another advantage in combat.
The main thing at night, if I go to afterburner in my F-15 that I've flown for 18 years, I've got this big flame coming out the back, so everybody sees me, anywhere from the guy with a gun on the ground to all the surface-to-air missiles. With the capability to go fast, basically without using this big flame out the back, Super Cruise, then I have a lot less susceptibility to the said threats.
Like the F-16 and the F-117, the basic design of the FA-22 is highly unstable and totally dependent on computers to fly.
You basically put the stick where you need it and the throttles where you need it, and it'll do the rest. It allows you to maneuver the airplane to the extremes and able to ultimately get the job done and still be able to maintain control.
The Raptor has one last trick up its sleeve, thrust vectoring. Inspired by the Harrier jump jet, it can direct the thrust from its engines up and down. It can't take off vertically or hover, but the system radically improves its air maneuverability.
The thrust vector capability of the Raptor gives it an opportunity to make it turn a lot quicker and continue to be able to basically point your nose. In a regular type of basic fighter maneuver, he who gets his nose in a weapons envelope first wins the fight. So with this actual thrust vectoring capability, we can really turn the airplane and essentially maneuver it twice as better as other airplanes.
At an estimated cost of over $120 million each, the FA-22 is one of the most technologically advanced military planes ever built. It is much more sophisticated and deadly than any enemy plane it is ever likely to come up against. Just knowing you might be up against a Raptor is enough to keep your aircraft on the ground.
With the F/A-22 Raptor, we can go down there and kick down the door and make sure as threats emerge, I can take them out. It's a lethal weapon, it's a lethal deterrent.
While the U.S. has been developing the Raptor, Europe has been creating its own super strike plane. While the U.S. has gone down the route of stealth with the F/A-22, Britain and its European partners have gone for super maneuverability while creating their own advanced strike plane, the Eurofighter Typhoon. It can cruise at supersonic speeds, carry out complex maneuvers at high G-forces, and has the most sophisticated pilot interface ever created.
My name is Craig Penrice. I'm the Eurofighter Typhoon project pilot.
Craig Penrice is stationed at Preston Air Base in England, where he has been flight testing the Eurofighter.
It's every fighter pilot's dream. I know that sounds very corny, but it's true. Cockpit that shows you, tells you everything that's happening in the world around you to allow you to be tactical. Thrust and maneuverability, carefree handling, all put together make it, a wondrous joy, fantastic airplane to fly.
Many fighters like the F-15 and F-16 have been highly maneuverable, but only at subsonic speeds. What sets the Eurofighter apart is that it can pull off these kinds of moves while flying supersonic.
When you aggressively maneuver this airplane, the roll rates that you generate are quite frankly startling. It really feels like you're on the outside of a washing machine being spun around. The roll rates will leave your head pinned to one side of the canopy if you're not careful. The airplane's capable of 9G, 9 times the force of gravity. This is a fairly tight turn in anybody's language. 9G is sort of currently recognised to be sort of physiologically a limiting factor.
The F-15 and F-16 are also capable of pulling 9Gs, but only for a second or two. The Eurofighter is different. It can fly at 9Gs for extended periods, but in order for the pilots to stay conscious, they must wear a specially designed Typhoon G-suit.
One of the drawbacks of all this agility and all this G is that it does weird things to your body. So through the years we've developed various G protection systems. But with Eurofighter being that much more of a high G airplane, we obviously have to give the pilot the best chance of not losing consciousness. So in addition to G trousers, we have inflatable boots in here. We connect the G-suit trouser connection here into the boot. That allows the air to be forced down into bladders that are in the boot. They inflate, squeeze my foot, and just further increase the coverage of this G protection device. A matching pair. Zipping up, slightly unique, going from top to bottom, so that the zip doesn't slip down under the forces of gravity. It's already down there, keeping me in there. Flying helmet, providing impact protection, crash helmet, providing communications. We take this airplane to places that, without this equipment, you just simply wouldn't survive.
This suit can keep the pilot alert and conscious while pulling 9Gs almost indefinitely, crucial when engaging the enemy at 12,000 meters. The Eurofighter is a lethal killing machine and can carry up to 10 air-to-air missiles, air-to-surface missiles, and anti-tank bombs. The targeting systems for these weapons appear on a head-up display or inside the pilot's visor, so they can aim and fire them without ever having to look down.
When you're in a dogfight with somebody, you really don't want to take your eyes off the guy you're fighting, because he can do something while you're not looking. So many fights have been lost in the past where somebody's looked inside the cockpit to check his height or his speed or his fuel and looked back outside, and lo and behold, the bad guy's disappeared. We don't need to do that with our helmet. We can keep our eyes locked onto the bad guy and have in our immediate field of view all the information we need. It's a huge tactical advantage.
The Eurofighter's 2 engines generate a combined thrust of about 40,000 pounds, pushing it to a top speed of 2,125 kilometers per hour, just below twice the speed of sound.
When you let the brakes off on the runway with full power, you're accelerating at 30 knots per second. That's about 35, 36 miles per hour every second. So that's 0 to 100 in car speak in 3 seconds. That's quite frankly stunning. You're pinned to the seat when you're going off. And it also means that you can be at 40,000 feet within a minute of takeoff, and only 5 miles down the road from the runway that you took off from. It's rocket ship territory there, really.
This staggering acceleration gets the pilot to the fight fast.
Translated into a fighting situation, basically for air-to-air, the plane that gets the highest, the quickest and fastest is going to have the best first shoot opportunity. So the higher I am and the faster I am, the greater range any given missile will have when it leaves my airplane. So I want to get as high and as fast as I can, as quick as I can. That's where excess thrust is always a bonus. Sight is life and speed is groovy. You can't fight what you can't see, and if you haven't got speed, you aren't going to defeat him either.
The plane's afterburners can effortlessly push the plane through the sound barrier.
Supersonic's just a number. Nothing happens. The controls don't reverse. It doesn't go all blurred. It doesn't shake. It just very smoothly slips through the speed of sound. No change in sound, no change in feel of the airplane, but you get there very, very quickly. We can accelerate from subsonic to supersonic in a heartbeat.
Like the F/A-22, the Eurofighter can maintain supersonic flight without its afterburners on, using supercruise, which not only saves fuel, but reduces the infrared signature of the plane, making it less susceptible to anti-aircraft fire. The Eurofighter is not stealthy. It has no need to be. It can fly its entire mission supersonically, and it is designed to fight its battles from a distance.
No self-respecting fighter pilot in a real engagement wants to get into a dogfight, but it's an area that you must be prepared to go into if needs must. A real fighter pilot wants to be up there, get as high and as fast as he can, shoot first and run away bravely and home for tea and medals. But there will be situations where a close identity or getting into a dogfight is required. So as well as the performance to get high and fast, you also have to have the ability to maneuver in a close-in dogfight.
Like other modern strike planes, the Eurofighter has an inherently unstable design. It is built with a triangle-shaped delta wing and 2 small canards on the front. To turn 20,000 kilograms of unstable metal into an agile fighter requires 3 massive computers, which control the plane using a revolutionary software system called carefree handling.
Carefree handling in the airplane simply means that I don't have a care in the world when it comes to maneuvering my airplane. The flight control computers are constantly looking at what speed height I've got and will limit their response appropriate to the state the airplane's in. So I don't have to worry about exceeding any limit. The airplane will look after me. You simply point the airplane where you want it to go and let go of the stick and it will continue to going there forever and a day. If you put all the things together, such as carefree handling, the thrust of the engines and the performance of the airplane, you take so much of the workload away from the pilot, and he simply just has to maneuver in relation to the other airplane. You don't have to worry about the limits, you don't have to worry about anything else, just get on and fight the fight.
The Eurofighter is the ultimate strike plane, fast, maneuverable, and deadly. It is the pinnacle of a development process that started with the F-15 some 30 years ago.
The F-15 and other contemporary fighters that I've been lucky enough to fly are all very, very good airplanes. But anybody climbing into this airplane will be able to feel and experience a distinct advantage over any of these contemporary airplanes.
The latest strike planes are the most advanced piloted military airplanes ever produced, but they may also be the last. As technology continues to develop with more aerodynamically unstable machines, capable of ever faster speeds and maneuverability, there is a problem. It is not computing, airframe design, or materials. It is human physiology. The human body simply cannot survive the astonishing G-forces the planes could achieve. It could be that the JSF, Raptor, and Eurofighter are the last strike planes ever to be flown by humans.